Hello the internet and welcome. On one of my previous videos I worked on 3 different Macintosh SEs and we looked into what was working and what wasn't. This is a quick follow-up on that video. We ended up with a motherboard which was not entirely working and some RAM which was not working. So what we're gonna do in this video, we're gonna test this RAM a bit further and see if we can recover it somehow, and also we are gonna test the other motherboard using the working motherboard that we found in that previous video. So let me thank today's sponsor PCBWay and let's start working on the RAM modules. 3, 2, 1, go. And it's working totally fine. Now let's check with the tech step that the RAM is okay. Sim test passed, so everything is okay. Now let's replace this 4 megabytes with this 2 megabytes. I will have to change the RAM size, which is done via resistors on this board. Let's take a look. To install 2 megabytes on this Macintosh, so 2 modules of 1 megabyte each, I will need to have the R36 resistor populated and cut the R35. Now, unfortunately, R35 has been removed, and this is supposed to be a 150 ohm resistor, which I don't happen to have. I have 100 ohms, and then I think I jump on 200 and something. So I will have to temporarily cannibalize the other motherboard, which happens to have a 150 ohm resistor clipped off, because this is configured for 4 megabytes. I'll get some spares, but for now I'll just remove this one and temporarily attach it on this motherboard. System is posting fine, let's double check with the tech step. And it's all good. Now let's plug the faulty, well, what we think are faulty memory modules, and let's test again. And the test failed, and if I check with 0, it says, well, SIM4? Why SIM4? We don't have SIM4, and this is probably configured for 2 megabytes. That's interesting, though SIM4 is this one, and the one that I labeled, that I marked as faulty, is this one. So maybe, you know, the routine is not perfect and it's identifying an issue with this bank, which happens to be the one where the faulty one is. Let's quickly double check that we are talking about this module, so I'm going to replace this module with a working one. And yes, the test is now passing, so it's definitely this module here which needs attention. Let's have a look under the microscope and replate the connector here, because it's not in the best shape. And no, it didn't, unfortunately, which was kind of expected. Does it still say SIM4? Yeah, it still says SIM4, which is kind of weird, but I guess it's like a quirk of the software, I'm hoping. So this unfortunately gets a big X, and it goes into the parts bin. And just out of curiosity, I swapped the SIMs around, and now it says SIM3 is faulty. So yeah, there is a pattern here, and I don't know why it says there's a fault with SIM3 and not with SIM1. But anyways, it definitely doesn't work. Now with that being done, let's go ahead and try and revive this board. As I said, the tech step was unable to connect to the board. Basically, it was saying there was either a SCSI or serial IC fault. I'm going to socket them both on both motherboards so we can swap parts. I can get the good ones from this board and place them into here, and we'll see if we can at least identify why this board is not working. Removing the SEC wasn't easy as expected. It's a 40 pins IC, and it took some time. And I also managed to damage one of the legs, which seems to be long enough to get into these type of sockets. But before moving on to the SCSI IC, doing any other work on this board, I just want to make sure that it still works. 3, 2, 1, go. Perfect, the tech step has managed to communicate with the board. Now I haven't got 2 serial cables, so I can't really test the SCC fully, but if the SCC wasn't working, I'd expect the tech step not to be able to communicate with the board at all. So, this should mean that it works. I can't do any further test. Now for the SCSI IC, I think I'm going to use a different technique. Removing the SCC IC wasn't easy. It's a big IC, and I think one of the reasons why that was difficult to remove was that the solder on this side of the board was not being sucked away from the other side. And one reason is the board was not preheated. So obviously everything is cold on this side, and the solder just didn't flow enough. Number 2 is that the solder on this end, or like everywhere on the board, is a bit oxidated. So yes, I reflowed the solder on the other side. I don't think it manages to flow on this end. So first thing first, I got the board on a preheater. I'm not going to use silly temperatures, but that should help. Something like 100 degrees, something like that. Number 2, I think I'm going to use my very small 210 soldering tip here. And I'm going to use lots of flux on this side of the board and just touch the solder on this side of the board just to remove the oxidation. Let's see what happens. It's not going to be easy. There's lots of plastic connectors around which can be replaced. I mean, these are nothing unobtainable, but ideally I don't want to damage anything, but fingers crossed, I'll do my best. And it took quite some time. It's not an easy task, but the process was definitely better. I didn't damage absolutely anything. Now, the only thing is that I'll have to do the same on the other board, but maybe I'll do that off camera. Anyways, the chip is back on the board. As before, let's test it because I want to make sure that everything works. I haven't damaged anything. 3, 2, 1, go. Oh, that's not good. No. Why? Okay, we have an address error. Could it be maybe the RAM modules for whatever reason, or something happened to this board? No, it was working totally fine. No. No, the error is still there. Oh my gosh. Let's check with the tech step. Have I damaged my working board? Oh no. Well, according to the tech step, the SCSI chip test is passing. Also, the RAM is passing, so I'm not sure what the problem could be. And also, all the bus tests are passing, and the Macintosh was reporting an address error, I think. I'm not sure what happened. This seemed to be working totally fine. Well, I didn't do anything, I just restarted without the tech step and now it's booted up. The mouse is not working because it's not connected. I'm just wondering whether I transferred the instability to this board from my own board with that ADB chip, with the one that I reprogrammed, because this is more or less what I was experiencing with the other board. It's working and then it's not working. I don't remember seeing the address errors, but it was this kind of weird things that doesn't work for a couple of minutes and then it starts working and it's totally fine. Let me try and plug my mouse and make sure that everything works. Aha, well, it seems to be crashing when the mouse is connected, which is working, by the way. Let me try again without the mouse. And look at that, without the mouse, it does work. Let me try and reset the ADB chip. And no, this now refuses to run with the mouse connected. I guess my only option at this stage is to grab the original ADB chip and try with that. And would you look at that, it works. So there's something with the ADB which is causing these weird instabilities. I remember having more or less the same issues. It completely doesn't work and then it starts working. I'm wondering whether I just got a bad IC. Maybe I should just get a replacement and program it, because this is working. But anyways, for the purpose of this video, the SCSI IC is now socketed, the SSC chip is now socketed. I think what I'm going to do now, to not bore you to death, is I'll socket the ICs on the other board off camera, and then we'll start swapping things and we'll see what happens. And I'm asking you a question, you can leave a comment down below. Which chip do you think I should start from? Remember that the tech step was saying SCSI or serial chip. And when I test the board by itself without the tech step, it doesn't boot basically. It gets to the point where it's supposed to boot and it doesn't boot. So what do you think I should start with? Let me know down below in the comments while I socket those two other ICs. And if you need a hand with a PCB expansion board or a 3D print for your classic Macintosh, well, PCBWay can probably help you with that. There are plenty of free projects online. This is the CR2032 battery adapter for the Color Classic. All I have to do was to find the Gerber file of this project, upload it on PCBWay.com, and the system is more or less automatic. Just choose a postal service and the PCBs will be delivered at your place. And PCBWay can also help you with 3D prints, metal sheet fabrication and CNC machining. And don't forget, it's PCBWay 11th birthday. Take a look at the celebration page on PCBWay.com. There are quite a few coupons that you can use, and there's also a little draw which you can try. I tried it myself and I actually won 2 items. So take a look at PCBWay.com and let me thank PCBWay for sponsoring these videos on my channels, because their help makes these videos possible. So thank you very much, PCBWay. Now let's continue with these 2 Macintosh motherboards. On the ADB problem, stay till in the end because I'd like to share with you a few things I've discovered meanwhile. But for now, let's keep testing this board. First thing first, let's make sure that the board is doing exactly what it was doing before, which is basically getting stuck at the booting screen. 3, 2, 1, go. And as before, it's stuck on the screen, the mouse is working, so it seems like we didn't damage anything, and the situation obviously isn't changed. Now, it's swapping time. So did you leave a comment about what you'd like me to swap? Now, obviously, I can't see future comments, so I'll have to make a decision myself, and because it's getting stuck after the testing, so the mouse is already there and everything, I think I'd like to go with the SCSI. because chances are at that point the serial port is not being used, but what's being used is the SCSI IC to access the blue SCSI. So I'd like to swap the SCSI IC and see if that solves our problem. Three, two, one, go. Hey, would you look at that? It's working here with the SCSI IC. So we found our culprit, if I'm saying that right. Mouse is working and everything is working fine. So this is our problem. Now, since we have the tech step, let's plug it up and make sure that everything works on this board, because we couldn't run any tests before because of that faulty IC. Tech step this time connects. Let's run the logic tests. ROM checksum passed, base RAM passed, ROM size is correct, buses passed, RAM test passed, VIA test passed, clock test passed, PRAM test passed, SCSI test passed, which is good, Swim test passed, sound test failed. I didn't even have the cable connected, but I could hear a tone out of the speaker. I guess that's it. An ADB test also passed, so fantastic, the motherboard is now working totally fine. I can't test the serial chip, unfortunately I haven't got two serial cables, but everything else looks to be fine. It posts, it boots, it goes into the operating system. I don't see why it should have further problems. And now I have a motherboard, which is the other one, which has most of the chips socketed. I think I might want to go ahead and socket the ADB and the VIA. I might do it whenever I need to, and that's going to be my little test motherboard, with the chips ready to come out for diagnostic purposes. Why not? A few days have passed, I've got a couple of ICs delivered, and I'd like to test them with you. The first one is this Logic L5380PC-2. Apparently it's pin-to-pin compatible with the SCSI IC, so let me try and swap the SCSI IC that I've just swapped on this board and see if this works as well. 3, 2, 1, go. Aha! Well, the text now says SCSI has zero problem, so well, it looks like that IC is not really compatible, I think. It looks like there is some kind of incompatibility, or the chips have been sold are not good, they're fake or they're damaged or anything. They definitely look brand new. The only thing is, can I actually boot from my blue SCSI using this SCSI IC? Let's try that. And yes, well, the system is starting totally fine. So this is another little quirkiness, that this IC is working when it comes to actually working with SCSI devices. But when it comes to the tech step, well, the tech step doesn't like it. Well, the hard drive is passing the Mac Test Pro, the SICK test, the simple one. Then there's a bad sector test, which is going to take forever. I don't see an issue with that chip, so I have to assume that it's only a problem with the tech step. So let's assume that these chips are a suitable replacement for the SCSI ICs, and happy days. I've got a fully working board with all the chips, and I can put back the original SCSI IC on the other board where I borrowed it basically to make this work. And meanwhile, I've spoken with Max. He explained me that I should be able to test a SCSI IC by setting the Mac into test mode manually, which should happen by pressing the interrupt button, which should be this one, before the system is booting up. Apparently the issue is just a timing issue between the chip on the motherboard that I'm using, this Logic IC, and the one which is in the tech step. But if I set the Mac into manual mode manually, the timing issue is basically bypassed, and the Mac should be able to pass the SCSI test using that IC. Let's give it a go. Powering up the Mac in 3, 2, 1, go. And interrupt. And we should have, the SAD Mac here. So in theory, I should be able to just run the test now without having to get into test mode. This is already test mode. And would you look at that, is true. This is totally working. So it's just an issue in getting the Mac into test mode, but the SCSI IC is working with the OS, and it's also working with the tech step. Just it can't get into the test mode. So thank you, Max, for giving me that hint. I'm really happy to see this passing. At least I know that the board is now 100%. Now the next thing I'd like to try are these chips here. These are PIC ICs, similar to the ones that I used on the my original motherboard, the one that works-ish, for replacing the ADB chip. Now on that motherboard I used the PIC16F87, and I've been told that the PIC16F88 might be a better match, though apparently the code that is available on the internet, the one that was reverse engineered or tidied up by Tashtari, is kind of basic, so I haven't got great expectations. But I just took the opportunity to get these chips, and there is a little backstory about these chips. It's quite curious. I ordered them from AliExpress, and after a couple of weeks I received an empty bag. And I went online to file a complaint with AliExpress, and I realized that the seller of the chips, meanwhile, had sent me a message, and the message said, "Hey, the price meanwhile has increased. If you want to receive the ICs, you need to pay extra money, or you can get refund." Now, I missed that message because usually messages from AliExpress are just junk and commercials and whatever things I'm not interested in, so I completely missed it. And rather than not sending the item, because I think AliExpress wouldn't like when the item is not being sent, they sent an empty bag. So, well, I asked for a refund, I got it, I left a negative feedback, and these are coming from, obviously, another seller. Also, meanwhile, unfortunately, I know this is gonna hurt a bit, I dropped my PIC IC, the ADB replacement chip, on the floor. I didn't realize it, and basically I stepped on it. So this is this is the state of my ADB chip. I think I can recover it with some hot air and a little bit of patience. But what I'm going to do now, I'm going to burn the same image on these 88 IC, and then we're going to test it. Number one, I'm curious to see whether the tech step is going to pass the ADB test. Most importantly, whether the system becomes a bit more reliable, because with this IC, we've experienced issues, so hopefully with the 88 it's going to work better. I have no idea. So let me straighten the pins of this poor thing, flash this PIC 88 chip, and then we'll test it on my own motherboard, the one that has a socket for the ADB. The PIC 87 is in the programmer. I've loaded Tashtari's code in here on the software. Let me do a quick verification. And the code verifies totally fine, so there's nothing wrong with the code in the chip. So the issues we've been seeing could be just the code not polished enough, I don't know, or maybe it could be a defective IC that works intermittently. I don't know, it's gonna be difficult to find out. What I wanna do at the moment is to overwrite everything anyways, just in case. That's it, overwritten. Now let's replace the IC, get the 88 in the machine itself. Out of curiosity, let me read it. This comes from AliExpress. It should be empty, I guess. It is completely empty. Perfect. So let me load Tashtari's code. There we are, and now I can program it. And it's programmed again. Now let me install this 88 chip in the original motherboard, the one that's supposed to work, and let's see whether the tech step, for whatever reason, likes it, and most importantly, if everything seems to be working fine. 3, 2, 1, go. Would you look at that? Well, the mouse is working, even though it's intermittent. So clearly we have an issue with the ADB, but this is exactly the same error we were getting before. So I would say no, this hasn't improved the situation at all. But now I know that it's definitely the chip. There's nothing wrong with my board. I don't understand. There's people online saying that this code is working, and obviously I'm not pointing the finger at Tashtari or Kai Robinson that did a stellar job just getting this working. But clearly it doesn't work for me, and honestly, I don't remember the mouse stuttering with the 87. Let's plug the 87 real quick and see if we have the same error. The error message is the same, it's not just error, but now the mouse is stuttering. So let's plug the other IC and see if the mouse is also doing that. Well, we have the same error message, and the mouse is not even moving this time, so it's even worse. But I have a feeling probably if I had restarted the Macintosh with the other IC, it would have probably ended up in something in a similar situation. I think it's kind of random. And I suspect that after restart, now the 87 is doing what the 88 was doing before. It's stuttering. So no, it's exactly the same behavior. It's a bit random. What puzzles me a bit is that I know that this chip works, because eventually I know that this Macintosh will manage to boot up. I'd like to try and warm up the board a little bit. If that changes anything, it won't tell me anything, but I'm just curious. And now it doesn't seem to be working at all. I know it used to work, but I'm 100% sure that there's nothing wrong with this board, because with the same IC, I had the same error on a different motherboard, and both boards are working totally fine with the genuine Apple ADB chip. So I really don't know. All I can do now is to feed my findings back to the community, and hopefully this is going to help for a future release. At the moment, the only thing is that this board is unusable. Basically, I'm missing one ADB chip for 3 boards, and this chip seems to not work with me. Now, before I completely give up on these ADB replacements, I asked some help on the forum on 68KMLA, and Tashtari came up with a couple of ideas. The first one is to check that the configuration is correct. These 2 addresses should be these 2 values. And here on the software, which is a bit on the small side, but I can see that these config words are exactly what Tashtari said, and Tashtari actually confirmed that that is correct. The other thing which is far more interesting is that there is a register called OSC tune, which can be used to nudge the clock rate 12.5% in either direction. And Tashtari has done some calculations, and apparently with this register set to -27, which is 100101, the instruction clock should go from 500 kHz to 447 kHz, which should be much closer to what the original ADB chip was using. So that's hopefully going to remove some timing issues this replacement ADB has been having, and someone has been using an external oscillator to make it perfectly matching the original ADB. So let me download this code that Tashtari kindly designed and made for me to test, and then we'll try again on the Mac. Okay. Is this working? Wow, would you look at that? It's worked out of the bat. With the other one, I couldn't get it work at all. Actually, let me restart first and try this again. Seems to be working totally fine. Amazing! We fixed, well, Tashtari fixed the ADB. I'm really happy, because now it means I have 3 working boards and not 2.5 basically. So fantastic! We fixed the ADB. Well, Tashtari fixed the ADB. No, it's not working well. Moo. And no, this is the same chip with my other motherboard, and yes, it boots up, but the mouse is intermittent, it's on and off, and I believe that if I fit the original Apple ADB, this is working totally fine. Let's check real quick. Yes, the mouse works totally fine with the genuine ADB chip, so this is ruling out the board or any issues with my system. There must be still something wrong with the code. We definitely improved on it, because now at least the system is working, but I'll feed it back to Tashtari, and hopefully my finding will help to get a further improved version. The last thing I'd like to try before giving up this ADB replacement project is to use an external oscillator. The motherboard is providing 3.6 MHz to the PIC, and the PIC is dividing it internally by 8, because this type of PIC is much faster than the one used by Apple apparently. Now, the original PIC from Apple was able to execute 1 instruction cycle every 8 clock ticks, but a modern replacement is capable of executing 1 instruction cycle every 4 clock ticks. So without having to rewrite the whole code, Tashtari used the internal generator at 2 MHz. But the clock provided by the board is not 4 MHz, it's 3.6, so using 2 MHz on a faster chip results into a slightly faster operation from the chip itself. And that might be the problem, so what I'm doing here, I'm using the external clock and I'm dividing it by 2 to compensate for the faster chip with a flip-flop, which is this thing basically flying up in the air. You can see the flip-flop in this case as a frequency divider. It divides the frequency by half. So we got 3.6 MHz coming in and 1.8 MHz coming out, which is again a bit slower than the 2 MHz that the original code is using. So hopefully that is the solution for our problem. Now the wiring of the flip-flop is very simple. I got 5 volts and ground, of course, and then the clock, the 3.6 MHz coming from the motherboard, instead of going into the PIC itself, is going into the flip-flop on pin 11. From pin 11 is coming out of pin 8, which is going back into the flip-flop on pin 12, and then we have an output of 1.8 MHz on pin 9, which is going on pin 16 of the chip, of the PIC chip. And finally we have pins 13 and 10, which are driven high, so they're tied to 5 volts. I haven't tested this myself, so hopefully that's gonna work. Let's give it a go. Let's power up in 3, 2, 1, go. Well, no, the Macintosh is stuck on the memory check screen, so something is not working here. It's not even posting. But the flip-flop is working. I have 1.8 MHz going into the PIC. So I don't really know what's going on here. I'm not a PIC expert, so I can only revert back to Tashtari and see whether there's anything that can be done. Now, there is one last thing I'd like to try before wrapping up this video. And it's to test that DIMM CRT with a different analog board. I've been thinking whether the CRT is actually completely very spent, very tired, or there's an issue with the analog board. So what I'm gonna do, I know this is the good CRT with a good analog board, of course. I'm going to briefly test the other CRT to make sure it's still very tired, and then I'm gonna install this analog board on the other chassis and see whether there's any change. I doubt it, but you know, just out of curiosity, I want to make sure that the analog board, both analog boards, are working totally fine. What? Why? Well, I don't know whether I had an error message before, but anyways, this is it. I don't know how much that translates on camera. I'll try and lock the exposure so we can compare the before and after. This is with everything maxed out, and if I'm not mistaken, the brightness on the analog board is also maxed out. Yes, if I increase the brightness on the analog board, I see the retrace lines. So this is the maximum I can do without seeing the retracing line. I can actually probably see them a little bit. So yeah, I think it's just the CRT. Yeah, I can see a little bit of the raster around it. I think I'm gonna swap the analog board. It's the easiest thing. Swapping CRT is not exactly super easy. I'll get the analog board of the Mac that we just put away. We know that that works totally fine. It's pretty bright. The screen is pretty bright, and we'll see if it changes anything. What do you think? Leave a message down below and we'll find out, I guess, in a minute. No, it didn't. The CRT is definitely, unfortunately, very tired, and there's nothing that we can do about it. It's just, it reached the end of its life. So I guess we reached the end of the video. I really enjoyed the troubleshooting process of the motherboard. I'm really happy to have a working motherboard again, like 100% with this SCSI IC, though it's not passing the tech step, but who cares as long as it works. I'm a bit disappointed with the ADB. I can't get the ADB to work. I'll again report it back to the community, see if they come back with anything. Because right now I was able to revive that motherboard. I have an extra SCSI IC, but I don't have an ADB chip that works on any of my motherboards. So I'm short of one ADB chip. And for now, there's nothing I can do besides looking online and see if I can find a genuine working one. And I'm also happy to have determined that this CRT is gone, basically. It's reached the end of its life. Someone on the previous video left a comment about trying to rejuvenate the CRT using one of those CRT machines. Now, number one, I haven't got one of those machines. Number two, bear in mind that those machines, they don't do miracles. They just squeeze a little bit extra life from the CRT. The CRT will probably die even faster after it's been rejuvenated, most of the time. It's not rocket science. But again, there's no magic behind it. If when the CRT has reached the end of its life, you can give it a little bit of injection of life with one of those things, but it's not going to be a brand new CRT out of the box, unfortunately. I hope you enjoyed this journey into old Macintosh machines. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my main channel if you like this kind of things. Don't forget I'm on Facebook and Patreon, and if you don't want to become a Patreon supporter, well, there is a free tier, so I do appreciate your presence there, even though you're not contributing financially, which is very much understandable, and the link is also down below in the description. If you don't want to join me on Patreon, which is very understandable, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to do anything, it's also very much understandable. I thank you for being here, and I hope you enjoyed the video. That's it for today. Thank you for watching, and hope to see you soon here on my channels for my next videos. Thank you very much, and goodbye. Bye bye.